Hey everyone, in this video we are on Chapter 6 of Practical Object-Oriented Design in Ruby. It's acquiring behavior through inheritance. So inheritance is the concept of sharing behavior and characteristics from one object to another. And one real-world example for you, birds, humans, and lizards, for example, could inherit from a vertebrate class, because we all have a spine object in our bodies. People and dolphins, for another example, could inherit from the mammal class to get the behavior of being warm-blooded. Sandy says inheritance is a way to do automatic message delegation, which means a forwarding path for not understood messages. So in other words, if an object of the human class gets hit with a message requiring it to do a live birth, but it doesn't have an action on it directly, perhaps one of its parent classes does. And in this case, the mammal class would have that behavior. So we start out with a bicycle class that's already defined and add a subclass of it, which is mountain bikes. They're slightly different. And at this point, it makes sense to make a road bike class and a mountain bike class and have those inherit from the greater bicycle class, which will hold the shared characteristics and behaviors that they both have, while the lower classes define the behaviors and characteristics unique to them. In this case, the mountain bike has full suspension, the road bike has handlebar tape, and so on and so on. We have a quick detour here to show you what happens if you don't use inheritance, right? You get a really long class. and Sandy paints this in a negative way, or as a negative way of building your classes, and the reasoning makes sense. If you have case statements or conditionals like this, this is a lot of lines, and things can just get tangled up and unwieldy if you're not careful. You know, this is a simple example, but it could easily be a lot more. So best practice is, if you see something like this showing up, it's a suggestion that you might want to try using a subclass. And you can discover places where differing classes with inheritance make sense if you find yourself writing if-else, case statements, etc. As we covered earlier, inheritance is a way of sharing behavior and a way of automatically forwarding messages that a given class doesn't understand. And I'd like to call out that whenever you make classes in Ruby, you're actually inheriting from another class. All objects ultimately inherit from a superclass called object with a capital O. And I would like to show you an example of inheritance and inheriting from the object class. So here I'm just going to make a class called yay, and I'm going to give it one method. So we can instantiate this class, and if we do a.high, what do you think is going to happen? It'll put high. So that's great. And there is one method in this whole class, right? Well, not necessarily. If you do a.methods, you'll see that there's actually a lot of things that we can call on it. In fact, methods is itself a method that I called on A, even though I didn't define the methods class in here. So as it turns out, there are actually 57 methods, not just the one that I defined here. And so this is all inherited behavior from parent classes from the object superclass. Inheritance can be drawn with a UML diagram like we've seen in other contexts. And in this case, it's the class name with an up arrow pointing from the inheriting class to the class that it's inheriting from. So now that we've looked at how to do it right, we also have to check out some of the ways that it can be done incorrectly. In Sandy's example here, calling super without refactoring the bicycle class itself to take road bike specific behaviors leads to having a mountain bike that's just a road bike with add-ons. In this case, it's a road bike with suspension. But that's not what a mountain bike is. So to do this correctly, we have to take out the road bike specific behavior from the bicycle class and put it into a road bike class. And then at that point, it'll be safe to inherit bicycle into the mountain bike class. We talked at the beginning of the chapter about starting with a concrete class. Now that we're talking about inheritance, we need to go on to thinking about abstract classes. And that's what the bicycle class turns into. So why do we say it's an abstract class? We can say that because there will never be in our code an instance of bicycle. We took away its ability to be a complete bike in favor of having its behavior shared across multiple types of bikes. And so even though ultimately what we did to the bicycle class was subtractive, it serves the greater purpose of making our future bicycle classes more concise. So Sandy says that the behavior common to all kinds of bikes should be in the bicycle class. This is like size and spares. These are the attributes. And the way that they're implemented is slightly different though. So for the road bike class, you could inherit from the parent bicycle class, but a mountain bike has different ones. Having super here suggests that it's inherited from bicycle class, but if you haven't already put a spares method in the bicycle class, it'll give you this no method error. And so that's something that you have to do. You have to add spares into bicycle and then perhaps remove these or modify these to the unique one, which we'll get onto later. But this is what it looks like. So all of the shared ones are initialized in the bicycle class, and the individual defaults get set in the subclasses. Now the next section is really about future proofing. And we saw that for each of the subclasses, there's the individual default value that gets initialized for that class. But when you make a new class that inherits from bicycle, and if you forget to put in default tire size, the default tire size method, then when you try to call it later, for example, this recumbent bike, you try to call it later and it says undefined local variable or method default tire size. And that's because it's expecting either recumbent bicycle to have that or bicycle to have that. And so you're sort of left wondering, like, okay, why doesn't this work? So the way to rescue that error is to put a default tire size method in the bicycle class itself. And you're not passing any variables. You're not saying like, 9 speed or 2.1 or whatever. You just say raise not implemented error. And in fact, you could give a somewhat more verbose error if you'd like with this content. That error basically says, okay, you have to define a default tire size method in the subclass. The reason that this works is that if you have a default tire size method in the subclass, then the superclass method won't ever get called. But if your subclass doesn't have that method, then it'll inherit from super and the error will get thrown. Very clever. What we did with the attributes before, we can do again in a different way with the spares. The mountain bike class is expecting its parent to have a spares hash that it can insert into, but it doesn't yet until now, which is this down here. And so now this will function properly. The last piece of the chapter pertains to decoupling your subclasses with hooks. The way that this works is that the attributes, in this case local spares, are received in the superclass as several common ones, and then the unique ones are appended onto it. So the book is laid out a little bit out of order for this to make sense, but basically, see this method here, it has these two common ones in a hash, and then it says, okay, merge whatever comes from local spares. So in the case of road bike, local spares has tape color. In the case of road bike, tape color. In the case of the recumbent bike, local spares is the flag. And when it goes back to bicycle, it'll merge whatever whatever came from that method in with tire size and chain. So that's all I have for chapter 6. I hope you enjoyed it, and I'll see you guys in the next video.